loud, maybe. There we go. All right, let me share. PowerPoint, everybody's favorite thing. Maybe, oh, I have to click the actual share button. Now we're sharing. All right, everybody. Welcome to SciJug, Central Iowa Java Users Group. We are not in Central Iowa right now because we're all virtual. Some of us might be, but it's awesome for people that are not in Central Iowa to have an experience and kind of learn something new tonight. So we are the Central Iowa Java Users Group. No Fluff Just Stuff's a great sponsor. Source Allies does all of our social media kind of stuff, and then JetBrains has been nice enough to give us some licenses to hand away here at the end. So hang on for that. For SciJug, for those that don't know, we are a volunteer-led user group for Java developers in the Central Iowa area. We've been going mostly virtual, so next month will be virtual as well. If you like what you see here, come back next month, same time, same place. And then we'll be in person, hopefully in March. So if you're in the Des Moines or Central Iowa area in March, feel free to come in and check us out. We're all about learning, teaching, sharing, networking, anything about learning and growing in your careers. And then a little plug, can I speak at SciJug? The answer is yes. We're open to anything, 15, 30, 60, an hour and a half, 2 hours, whatever you're looking for. Lightning talks, find a buddy, bring them in. We have a small bias for JVM languages, obviously, but we are not opposed to if you have something that's software development adjacent, feel free to bring it in. We are on Sessionize. You can go ahead and use Sessionize Central Iowa Java Users Group link if you want to fill that out and get in contact with us to speak in the future. And feel free to hang around at the end. So anybody that's still on the call at the end that would like we have some subscriptions to JetBrains, any of these suite of tools that you'll be interested in. We have 2 raffle tickets we're going to give away tonight. So hang around. We'll raffle those off after the presentation, and you'll get a 1-year subscription to one of those products. And with further ado, Eric, I'm going to let you take over, man.
All right, thanks very much. It's very similar to the kind of the intro that we do for our group.
Sweet.
It should probably help if I would share my screen here, right? So that everybody can see what I'm talking about. Where'd the share button go?
It's always in a different spot.
Yeah, and as soon as I click this button, everything is gonna
Yeah, I know.
wish. All right, hang on here. I'm trying to get like the chat and the videos in a good place where I can see stuff. Yeah, so my name is Eric DeAndrea. Where did everything go? And as I was saying to the organizers as we were chatting beforehand, I have a new computer here, so I'm still in the middle of getting it set up. So what could possibly go wrong tonight, like with live demos and a computer that's brand new and whatnot? But with the topic of AI and whatnot, so having I was able to get my company to splurge on a non-standard model with some heavy GPU horsepower. So that's always a bonus. A little bit about me, I talked a little bit. I said that it kind of looked like the slideshow that I'm familiar with. So I'm in the Boston area. I live in New Hampshire, but in New England, everything is close to each other. So I'm only about a half an hour outside of Boston, and I'm one of the board members and organizers of the Boston Java, where we've gone under the ACM umbrella to help. They provide services to us, the Association for Computing Machinery. So we've branded under them as part of kind of coming back from COVID. They help us out with a lot of stuff. So I'm a board member. I help organize the group. I travel the world. I speak at a lot of events. I'm a Java champion. I've been doing software development and Java development mostly for 25, 30 years. I currently work for Red Hat. Before Red Hat, I worked in financial services for most of my career, financial services and insurance, wealth management, institutional management. But even throughout my career, I've always been involved in open source, either as a consumer, and then once I got my companies on board, allowing to be contributors. I was a long time contributor to the Spring, and mostly in Spring Security and the core Spring framework, not as much in Spring Boot, but a lot of stuff in Spring Security. Currently, I contribute to LangChain4j, which is the topic for tonight, and the Quarkus ecosystem around LangChain4j and the Quarkus project in general. I'm not an engineer on the Quarkus engineering team, but I am a contributor to it. And other projects like WireMock and Microx you'll probably find me in a lot of different open source projects that I'm involved in. Um, Me up in the top, I don't know if I'm here or here or here or wherever you are. My picture up there. I live in New Hampshire. I live up the lakes region, so I love to be out in the boat. I just love to sit out there. I could go out there all day and just putz around and spend the entire. That's kind of my background here. Is a picture. That was kind of the last ride of the season in October. We took that while we were out and about, so seeing the foliage and whatnot. So that everybody has their happy place. That's my happy place. So as far as like questions and whatnot, feel free to interrupt me as we go. Speak up. I can't see the chat, so if there are any questions in the chat, if someone can bring them to my attention, I can see the videos, so don't be shy. Come off, turn your video on, and ask me. I'm certainly no expert in this topic, so I may not know the answer, but I'm happy to, part of this is, this space moves so fast, like a week is an eternity in these technologies. Like, oh my God, that's like so last week. Like you're like 5 versions out of date. So I may not know all the answers, but I'm happy to have conversations about whatever. I'm going to be busy over the next couple of weeks. So after tonight, next week, I'm taking a road trip up to Canada. I'm doing a couple jug tours up in Montreal and Ottawa. Next week is also the J Champions Conference. So it's a 4-day online virtual conference that's free. Starts on Thursday. It's Thursday, Friday, and then the following Monday and Tuesday, where there's 7 sessions each day on different topics that they're all delivered by Java champions. So I'm going to be doing a talk there on this 26th, that Monday. It's either the Monday or the Tuesday. I don't remember which. And then I'm going to be at JFocus up in Sweden in February, and I'll be at DevNexus in Atlanta in March with a bunch of different talks. As you can kind of see, there's a theme with a lot of my talks here. You see the word testing in there. I'm kind of a testing fanatic. This talk today doesn't really involve much testing, but I kind of have a testing. I don't know if it's I don't want to say fantasy, but I kind of go overboard with testing, and I talk a lot about testing and testing practices and whatnot. So that's kind of one of my little side gigs. And I've written a book as well. So if I were in the room, I would go around and say, "Hey, who's heard of Quarkus?" And usually you don't get a lot of hands. And then I'd say, "Who's knows Spring?" And I'd get a lot of hands. So I wrote a book about looking at Quarkus through the lens of a Spring developer. We're not really going to talk. I mean, every example I have today is going to be done in Quarkus, but that the fact that it's Quarkus doesn't really matter, and I'll explain why that is in a minute. It's just the technology of choice. When we start talking about LangChain4j, it's really framework agnostic. So, and speaking of LangChain4j, there's this awesome book that written. I don't know if anybody knows Antonio, but Antonio Goncalves is I've worked with him a bunch of times. He works for Microsoft, and he wrote this book about LangChain4j. It's I don't know if it's free or if you have to pay for it. He gave me a copy. He released this back in October. And the forward, Dmitry Lubiarski, I think is how you pronounce it. He's the creator of LangChain4j. And he also works for Red Hat, so he's somebody that I work with as well. So I haven't read the book, so I can't tell you how good it is or not. Yeah, I've read Antonio has a lot of other books that I've read, and they're all good. So I have to imagine that this one's good too. All right. So enough about me. What are we going to talk about? I'd like to try and keep this interactive. This particular talk I did this the first time. It's actually a 3-hour deep dive. So, and even in 3 hours, we didn't have enough time to cover all the material. So there's no way we're going to get through all of this today. If you feel like it, if we get halfway through it and you want to do the rest of it, I can certainly come back another month and we can do part 2. What I'd like to do is because I don't know what people's like levels of understanding of AI and LangChain4j. So I'd like to do kind of let's cover the basics. And then when we start getting into like RAG and function calling and guardrails, if people have an interest or questions in certain areas, we could skip around. Or like I said, I can come back another time, but we're certainly not going to get all of this in today, not unless you want to stay here. Well, for me, I'm an hour ahead, unless you want to stay here till like 10 o'clock my time. So there is the links down the bottom. The slides, that's the link to the example code and the link to the slides. They should be there now. The QR codes will get you there as well. If the slides aren't there, somebody can ping me and I'll fix it later. But they should be there. And all the examples are in that repo. And you can probably see at github.com that it's not me. So I work with Clément Escoffier. He's the co-lead for Quarkus and the lead on the Quarkus LangChain project. So he hosts all these examples in his repo. But if you look at the commit history, you'll see my name all over. All right. So this is where if we were in person, I would ask who knows anything about AI or who's done anything with LangChain4j. Throw like a thumbs up or something if you at least have heard of it, know what it is, and are interested in it. Okay, a couple thumbs up. Okay. So for time's sake, what the way I typically started this, and I think I'm going to deviate a little bit, is kind of go through a couple different examples of different types, because when AI is a very broad topic, right? You know, you say AI, it's like, well, what do you really mean? So there's a couple different types of, or I mean, these aren't the only three, obviously, but there's a few different types of examples. I think everybody's mostly familiar with the chatbot, right? You open some website, you click a button, and you start interacting and typing with stuff. Part of what I like to talk a little bit about is the difference between AI as, I don't want to say replacing, because replacing is not the right word, but AI, like you're as a software engineer that's going to integrate their AI into their application, are you trying to emulate or replace a human, or are you trying to emulate or replace other software? Because I think there's a distinction and a difference between that. The typical chatbot example is, hey, I want to reduce headcount, or I want to interact or pretend to be a person and have that person do stuff, or have the thing do stuff on behalf of a person. But some of these other things are more helpful, or they're more, you have to think about it more as these things are software, and how do I connect to that software, and how do I interact with that software, and what concerns do I have or should I have with that software. So I'll show just a couple simple examples of some of these other ones. Is my font size in the IDE okay, or do I need to make it bigger?
I think it looks good to me, but I have a fairly large screen, so I don't
My eyes
Okay.
are getting bad, so if you could zoom it in.
Yeah.
know.
Yeah, I'm on a 49-inch screen with 5K resolution here, so I'll make it a little bit bigger. Is that better? A little more? Does this mean a little more? Or does that mean okay?
I'm good.
Good. If anybody can't see it, speak up or forever hold your peace.
There was
There's
there was oh yeah, I was gonna say there's
one.
one more in the chat that said one more
One more? Okay.
potentially
Potentially. Okay.
if it's possible.
Yep. It'll just be, it's like yay big on my screen, like, and I've got to like
Yeah,
scroll to read
you
it.
see each letter.
Yeah, pretty much. So all these examples, this whole examples, everything I'm going to go through, and they're kind of the way the repository is set up is it kind of goes in order of the talk. So like zero, we start at zero with the examples that I'm going to show, and each one is kind of ordered. So it's very, very easy and self-explanatory if you want to go through this stuff later on. The summarization thing that I like to do, I don't have enough time in the day to read everything that I want to read, right? So I keep like a laundry list of articles, like things that come out as I see people posting on Twitter or whatever. I kind of grab these URLs and I store them off somewhere, and then I have it like summarize something and then try to figure out like what do I actually need to go read, or are the cliff notes good enough? So something like that is you can see here that there's not a lot of code. I mean, even with the class, and I've got it as a full application that's a command line application. We're only, with all the imports, we're only talking like less than 50 lines of code here. So if I were to run this, and I'm just going to scrape redhat.com. Oops, what happened there? Oops. Got to be in the right project, right? So it's going to go out to redhat.com. It's going to summarize. And I am talking to OpenAI for all of this stuff. And oh, yeah, it costs money. All this stuff costs money. But I loaded my OpenAI account back last January with $5, and I think I still have like 65 cents left of everything. I mean, even I've done this talk like 3 times with 3 hours, and I still haven't gone through $5. So it's not like it costs a lot of money. So the way I use this is I'll just give it a laundry list of things. I dump it into a text file, and then like once a week I'll run this thing. I'll have it summarized and have it spit out the URLs for things, and I'll decide what I actually want to read, and then I'll go read it. So this is kind of like replacing software, saving me some time from doing stuff. The other kind of cool thing, I'm going to skip over the chatbot for now because I think we're probably all familiar with that, and I've got an example later on of the chatbot. The other thing is, I'm not so much into this, but Clement, who I was talking about earlier, is very big into handwriting notes. Like at every meeting, he takes a notebook with him and he handwrites his notes. And he's French, so his handwriting is atrocious, and it's French. All right. So I don't know if anybody speaks French. I speak a little French. So I took this. I don't know if you can see it. I'll make it a little bigger here. I wrote this and I scanned it in. I can't make it bigger. It says in my hand, my parents always said I was going to be a doctor because my handwriting is awful. It says, this is some text. My parents always said I was going to be a doctor. And then I actually wrote it in French. What do you think? Is my writing good or bad? Is what it says. So what we can ask the AI to look at it and to translate it, or not necessarily to translate it, but what did I do here? I gotta compile the damn thing. There we go. And so all it's going to do is it's going to start up again. It's like a very simple command line. Do you remember the OCR days? Like back like when in the 90s and 2000s, you had the scanner and you had to scan the thing in and you tried to get OCR to work. Like you'd put this document in, it would never be anywhere near accurate, right? Oops, I know what I gotta do. It's the wrong type of application. Quarkus dev. So I'm going to run Quark. This is a fully fledged Quarkus application. Uses JAX-RS. It's going to have a REST endpoint, so you can actually upload the file to the application with a description, and it'll give you back the translation or the OCR. So I'm just going to go into, and of course it opens on the other screen. Hang on, and I will definitely make this bigger. So if you're not familiar with Quarkus, I don't want to get a whole lot into Quarkus tonight, but Quarkus, when you run it in its dev mode, it has this live reload capability where you can just fire the thing up and start coding, kind of like Node.js. But the other cool thing is you get this dev UI. So any of the they call them extensions, any of the extensions that you have show up, and this thing is only available in the dev mode. The one that I'm looking for is, where'd Swagger UI go? Yeah, Swagger UI. So I don't have to curl my REST endpoints. So I'm going to go in here, I'm going to upload the file, and I'll say some handwritten text. And say, here's the extracted text in the image. This is some text. My parents always said I was going to be a doctor. And then it grabbed the language, even the foreign language and the French language. So replacing software that we're all kind of familiar with, from a blast from the past a little bit. And it's really like a lot of this class is just the scaffolding of the REST endpoint around this, and then the parsing. We're using JSoup, base encoding and converting it to base 64. But the meat of the meat of actually interacting with the LLM to do this, we didn't actually write any code. This is just an interface like that I wrote. I didn't write any code to actually do it. Quarkus gave me the implementation. And I'll talk about the relationship between Quarkus and LangChain4j and all that stuff. You'll see like this image URL thing that actually comes from LangChain4j. This image object comes from LangChain4j. It's like really easy and simple to do some of these kinds of things. So let's talk a little bit about what an AI, I guess first, any questions about what I just showed? Just some simple examples of stuff. And this is gonna be very code heavy. Like from each slide, I've got code, slide, code, slide, code. So please stop me if you have questions. So what are LLMs? Anybody building applications with LLMs? Like you could give a little thumbs up if you're currently doing that today. No. So what are large language models? So today, these things are based on what's called a transformer strategy. And I am so not a mathematician or a statistical analysis or that type of person. So I kind of blindly take it on faith that these things actually work. But under the covers, it's a big neural network with lots of functions, lots of weights, and every single request has to go through this neural network. Don't ask me what a neural network is. I can't give you a good answer for that. Again, I'm not a statistician or a mathematician. But what the job of the last layer of that model is for doing prediction. So the LLM understands and recognizes, predicts, and generates text. The LLM doesn't know anything about the context of what you're talking about, right? You might think it does because it seems to respond accurately based on what I'm asking for, but it really has zero understanding of what context you're talking about. All it does is it's using a mathematical equation and a set of probabilities that, based on what it knows, what's the highest probability of the word that's going to come next. And that, I mean, whether you think that's simple or not, that's as simple as these models are. What's different about each of these, I mean, you've got like GPT, and you've got Claude, and you've got Mistral, and you've got this explosion of things. If you haven't been out on Hugging Face, go take a look out on Hugging Face. These things, what changes is the data that these things are trained on. So like, what data can it look at to help predict the next thing? How big is it, what it's called its context window? And the context window is how much data in a particular request can it deal with. And different models deal with different amounts of data and can deal with different amounts of data. So like, if you think about it, and we'll get into conversations in a minute, these things are, they're really dumb, and they're not reproducible at all. So like, the first thing you need to understand is, if you ask it the same question, you're most likely going to get a different answer. So like, software engineering, you're like, oh, the test doesn't run. What's the first thing you do? You go try run again. And if it works, then it's, wow, what the hell happened? It's got to be something environmental. But when you're dealing with LLMs, if you ask it the same question again, it could actually work the next time, because it's not, the answer you're going to get is not predictable. That being said, there are parameters that you can do that tweak it a little bit to say, like, how much randomness do you want it to use? How, like, not that it's going to be super predictable, but how, like, toward, if you had like a scale of predictability in randomness, like where in that scale do you want to be? And based on your use case and what you're trying to accomplish, whether you're trying to, generate text for a story, or you're trying to summarize, like when I'm summarizing these these sites, I don't want it to be making, can I say shit? I don't want it to be making shit up. I want it to be, to just look at what's there. Don't make anything up. Just tell me what the thing was about. I don't want it to be generating stuff and making up nonsense. So you can kind of tune, for your use case, tune what these things do. So essentially, when you feed it data or you feed it text, it's just going, and it's not even going word by word. It's going as, and I'll talk about tokens in a minute. It goes token by token, and I'll explain what a token is in a second. Is it's looking at what has it just done, and each time. So if you think about a sentence, like if it puts the word the next time it goes to the next word, it's going to reread what it's already done, and it's going to try to figure out what the next one should be. And then it's going to go reread. So you can think of like this recursive algorithm where it's continually going back and rereading what it's done so that it can help predict the next thing. But the big thing is, it doesn't have any understanding whatsoever of what it's talking about. It's not smart at all. They're also, the first L in LLM means large, and they are very large. Has anybody like played with ChatGPT or tried to run like a Llama and run any of these models locally on their machines? So a Llama is a good one. I run it on my machine. It's good for being able to run models locally on your machine. The models it can run, because of the largeness, aren't the best. So they hallucinate a lot. They don't give you the right. So like Llama 3.2, which is the one from Meta, is not a great model, because it'll do things that you don't expect it to do. Whereas like OpenAI is pretty good, Claude is pretty good, Mistral is pretty good. Llama 3.3 is very good. Llama 3.3 is 43 gigs on disk, and if you don't have at least 64 gigs of RAM and at least 20 cores of GPU, don't bother running it, right? And don't bother, if you have that, don't bother doing anything else while it's churning, because if you ask it one question, it's probably going to take 15 minutes to produce an answer, right? These GPUs, 43 gigs on disk, and if you don't have at least 64 gigs of RAM and at least 20 cores of GPU, don't bother running it, right? And don't bother, if you have that, don't bother doing anything else while it's churning, because if you ask it one question, it's probably going to take 15 minutes to produce an answer, right? The whole AI thing is into these GPUs because GPUs are really good at what? Graphics. And what are graphics? Graphics is statistical analysis, matrix multiplication, which is exactly what an LLM is doing. So that's why people say, oh, you can do CPU inference, but it's going to be slow. And that's, the truth. So Llama 3.3, for example, has what's called a token window. So 128,000 tokens. Again, I'll talk about tokens in a slide or two. A token isn't exactly a word. It's like a smaller version of a word. So as you're communicating back and forth with the thing, it's completely stateless. So if I ask it a question, say, hey, hello, if I say hello and it says hello back, and then I say, my name is Eric, and it says, hello, Eric. And if I ask it what my name is, it doesn't know what my name is. It's on me to keep the history and to keep sending the history back and forth. So if I want to have a conversation with it, I have to remember everything that I've done and everything that it said and feed it back its entire conversation history. Now, when you start talking about like scopes, if I'm building a REST endpoint, right, and I have an HTTP request or an HTTP session, you don't want to be leaking conversations between people. So there's lots of things to have to worry about. So you can start to see like the amount of memory your applications need to store these things is going to start to get big. 128,000 tokens means in any one request, I can only send it 128,000 tokens. It only understands 128,000. So if I've got a conversation that's been going on for an hour, I have to start pruning that before I can send it back because the model isn't going to understand. And every model has a different size. So that's like Hugging Face is really good for being able to look up quickly what these are. Granite is another model. It's put out by IBM. It's, I have to put it there because Red Hat is owned by IBM. It is not the best by any means. It's trained on 34 billion parameters. I forget what its context window is, but it's really small. It's only like 4 gigs it only uses 4 gigs of RAM, 5 gigs on disk. So you have to kind of pick and choose based on your use case. And different models are good for different things. Like if you're building a code generator, like you're asking it lots of questions about code or to write code for you, Llama is probably not the best model for that. You probably want a model that's more trained on code or GitHub or whatever. If you want to write a story, well, then Llama is probably a decent model for that. Different models are kind of trained for different purposes. And so the more parameters you have, the more parameters the model stores, the more stuff you can do. I mean, that's essentially it. The more the more stuff it understands is the more that you're going to do. So the bigger the model, the more capabilities it has, right? So whether you want to do, summarization is pretty easy. If you want to do like language understanding or code completion or translation or even things like comprehension or arithmetic, models are inherently not good at arithmetic. And so just as a sidebar, like if you ask, it'll probably understand what 3 + 3 is, but if you give it a complex math problem, it's not going to understand because it's a text prediction algorithm. It has no understanding whatsoever of what you're doing. So there's ways around that, and we'll talk about that. But that's just kind of one thing. You do not want your models to do arithmetic, especially if you're in the financial sector. Bad things will happen. I got one thing, Jody and whatnot. You're gonna have to just tell me when we're at time because, like I said, this is like a 3-hour talk, and I could just keep churning for 3 hours. So if we're getting close to time of when we have to shut off, I have nothing. I can go all night. So
We can do that.
So once you have the model, it needs to be run, right? Just having a model on disk doesn't really do you anything. The model's only one thing. I'm not even going to really talk about training a model. That's like the whole AI, ML, data science area that I don't know anything about. But once you have the thing that they produce, it needs to be served some way, shape, or form, right? And that's what things like OpenAI and Claude and Anthropic and all these cloud providers, they're serving their models. They've got, I don't even know how many thousands of GPUs in their server farms that are running all these things. I mean, we talk about like we want to be green, like LLM and AI is not a green technology, right? All the heat coming off of all these data centers running on all these GPUs. But it needs to run somewhere. So there's a lot of different runtimes. There's open source ones like VLLM and Kserve are free and open source ones. They all have different capabilities that they can do, whether we're talking RAG tools, things like that. Some can do it, some can't. Podman AI is a good one if you're looking for something on your desktop, like you want to be able to serve models on your desktop and that don't cost you anything. Podman AI is a good one. Llama is a good one. A lot of the models that are out there, like Llama, the Llama series from Meta, can run on a Llama as long as you quantize the models a little bit. You can run them with CPU inference. It is very, very slow. Like if you're trying, I run a lot of tests and I run a Llama in like GitHub Actions in my CI/CD, and like just issuing a query takes like 5 minutes to get a response back from a simple, hey, summarize this for me, like when it's running on CPU inferencing. So it's really better to have GPUs for this kind of things. What you kind of see today is most of these things expose some API, most of them REST. So like OpenAI has a REST API. Everyone has a REST API, and none of them are the same, right? We're kind of in the wild, wild west for now, and I think kind of from my own personal understanding it's kind of like a for now, because that's what we understand how to do. Like as developers, like this thing changes so fast and it's so new. Like we're not trying to invent the whole car at once. We're like got this new superpower engine with LCD screens and self-driving capability. I'm just going to dump it in my Honda and be happy with it for now, because that's what we know how to do. Whether that changes in the future or not, whether it becomes less resty or there's like direct APIs, I don't know. I can see that coming, but that's just not where we are right now. So most of these models, you're interacting with it through REST. Kind of like how we did, when microservices came on and you had all these databases sitting around and everyone was like, no, you don't talk to the database anymore. You talk to the RESTful service that's in front of it. And we built RESTful services in front of everything. That's kind of what's going on right now. And some of these models, like OpenAI, for example, the same API can do different types of things. So like one model serving runtime can do text generation, can do image generation, can do embedding computation, which I'll talk about that a little bit later. Can do document embedding through the same API. Llama can do that as well. And Llama is actually cool because it can emulate the OpenAI API, which is really nice. Like if I have an OpenAI client and I want to not pay to talk to OpenAI and I just want to use Llama on my machine, I can do that because it uses the same API. So it's kind of cool. So this might sound basic, but I figured I'd give everybody a baseline. When you deal with a model, you're providing the input, which is called a prompt. That's generally text, or in some cases, if you're doing like image recognition, it could be an image. But most cases, it's text, which is pretty different than most code or other systems that you're interacting with, right? Because either you have a UI and you click around, or you're interacting with an API. Here, you're just giving it text. And everybody says you should be nice. If you're nice in your prompt to the LLM, you actually do get better responses. I played with that, not scientifically, of course, but I did play around with it, and you do get better responses when you're polite and respectful to your LLMs. Treat them the way you want to be treated, right? So you use plain English or French or Greek or whatever language you speak. You give some instructions and you tell it and it tells it what to do. Now, there's different ways to provide instruction to it. If you haven't worked with these things before, does anybody have teenagers? No, you don't have any teenagers? Jody's raising her hand. It's kind of like talking to teenagers. For those of you who don't have, so do you have kids? Are they younger? Are they not teenagers yet, or are they past teenagers?
I've got what do I have? 7-year-old and a 9-year-old, something like that.
The fun
So it's
times
coming.
It's coming. The fun time. So if you want to get a glimpse as to what it looks like, start playing with ChatGPT, and you'll start to get a glimpse of how you need to talk to your teenagers. So
Can't wait.
You'll find out right away that like talking to the LLM and how to get what you want out of it is a skill in and of itself. So like people say prompt engineering, and I've seen it on resumes now, it really is a skill, because every model, if I take the same prompt and I give it to 2 different models, I'm going to get very different answers, right? Just like every teenager is different. I try to teach I have 2 teenagers, so I try to teach my teenagers to be respectful and polite and whatnot. And when they're not polite, they don't get good answers, right? So it's very similar. So it's kind of like a game. You've got to figure out how you want to talk to the thing based on exactly what the thing is, which means you blindly can't just switch your models like a database. It's not like, oh, I'm just using JDBC. I can go from Oracle to Postgres and I'm good. It's the same language. And it doesn't work that way. So when we talk about AI infused, and I don't know who coined this term, whoever did is probably getting rich right now, but we're essentially trying to take some software application that we have and enhance or extend it with some of these different capabilities that I kind of showed, like summarizing and chatbots and image recognition and whatnot. But that red arrow that's there, application to the model, is way more complicated than what people think. It's not like I said, JDBC, where you just make a JDBC call and issue some SQL, or you make an HTTP request over to some RESTful service and get some JSON back. There's way more stuff in there. Even the transport is the easy part. Like getting it from A to B is easy, but what you put in there and how you get responses back and how you detect what did it go off the rails, is it actually true? Like, do you have a good understanding of what it said? Yeah, it gave me back something. Is it factually correct? Like what it gave back? And I'm not even gonna go down that road about humanity and where we are now, but and it's non-deterministic. Like the same answer, you're not going to get the same answer back and forth. And if you think about security, any security folks on the line here? Everybody's a security folk, right? Because you have SecOps and you shift left your security, right? So you nod your head and say yes. So in terms of security, if you're, when I start to talk about tools, like if I want to be able to give my LLM access to do things on the application's behalf, like maybe if I'm building a customer support thing, chatbot, and I want to say, hey, show me my bookings. How does the chatbot know what my bookings are? Or how does it, if I'm building an insurance claim system, how does it know my customer information, right? Your applications have to provide that kind of stuff. Well, to me, like when I first started doing this, it's like, you remember back in the JavaScript days, like you could send a bunch of JavaScript over the wire and just blindly eval. And that's exactly what we're doing. And everybody is just okay with it. So like thinking about security and how you're going to block that is definitely a something you need to keep in mind. And I'll throw some things out there as we go. So there's a lot more things that are out there. So again, I talked a little bit about like the intended to replacing a human versus intending to replace existing software processes. So if that's something that you want me to talk about more in depth at another time, actually my JFocus talk focuses just on that. And I know JFocus is in 2 weeks and I haven't even finished writing the talk yet. So I can't do it yet, but I have a whole talk that focuses on how do you test and ensure that the non-determinism is acceptable and secure and all that kind of stuff. So you've got these models and you've got these processes should look familiar, at least the one on the top, right? As developers, you've got the data scientists on the bottom and these machine learning people that are going through this process, fine tuning the models, getting the models running, and then they throw it over the wall. And now we have this, our SDLC process, which goes through, dev, build, code, agile, blah, 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 blah. And everybody's got to kind of like coincide. So you need some kind of client or toolkit or something that's going to help you interact with this stuff. Because if I have to know and understand how the model works, like if I need to interact with it raw, like think about like trying to interact with Postgres without the JDBC layer, right? How would you do that? Would you want to reinvent that wheel every single time you went to a different database, right? So the toolkits that are out there are going to provide you the abstractions. Hang on one second. Sorry. Joy of work at being at home. Are these toolkits that you need to do? And I'm sorry, my office is like super hot. As soon as I shut the doors of my office, it gets really, really hot in here. So you really need a toolkit that provides some kind of abstraction. And in the Python and JavaScript world, if you've heard of it, it's called LangChain. It's been there for a while. It's pretty stable. I'm not going to talk about it because I don't really know anything about it. What I am going to talk about is LangChain4j. So this is aiming to be a toolkit, taking the ideas and the concepts from LangChain, but bringing them into the Java world with the Java idioms. Because Java, I've written probably 2 lines of Python in my world, and it wasn't a fabulous experience. But the way you do Java and the idioms behind it and the abstractions are they're very different, right? So just like copying it word for word just so it compiles in Java isn't the right approach. So that's where it started in October of what was this year? 2024, 2023. So that's when it like first came out, and it's very close to a 1.0 release at this point, and it moves so fast. Like a week, like I said, is an eternity in this space right now. So some of the things it does are harder to do than the Python version. Some are easier. It just depends on the idioms and whatnot. But I will say, oops. Its name is actually, so the creator of LangChain4j, he didn't at the time, but he now does work for Red Hat. And this name is going to change. I don't know when, and I don't know what it's going to change to, but it needs to break the relationship from LangChain, because of legal reasons, the name behind it. It's LangChain is produced by a company that owns the trademark LangChain, and the individual contributor had permission to use it, but now that it's kind of steered by a company, it can't do that. So there's legal reasons, but the other reasons are it's evolved to the point where it's diverged quite a bit because Java is so different than Python. So it has a lot of the same building blocks and pieces and nomenclature, but that's really like where the commonality stops at this point. Just over the last year and a half, it's really diverged. So it really needs to be its own thing. Like people can't just think that, oh, I know LangChain4j, I know LangChain, and vice versa. It really needs to be its own thing, and legally it needs to change anyway. So so that's another good reason. So it's a toolkit for building these AI infused applications, providing abstractions and building blocks for prompts and messages and tokens and vector stores and embeddings and all these different things, building a common toolkit so that you can switch from one model to another model without, you probably would still want to rewrite your prompts, but your prompt isn't code, right? You don't have to rewrite your code. So if you think about kind of the hierarchy and the relationship, so LangChain was there. LangChain4j was inspired by, that was the word I was looking for. I forgot that I had another slide, is inspired by. And that's really where the relationship and the commonality and the similarity ends, is the inspired by. Maintained by different people. And then Quarkus LangChain4j is something that kind of sits on top of LangChain4j. It uses all the abstractions and models, but implements them in I'll just say the Quarkus ecosystem. There's Spring Boot starters for LangChain4j that do similar things. They provide like auto configuration and conventions that are familiar to Spring folks, but using the building blocks provided in LangChain4j. So you could use LangChain4j in any Java application. There's no dependency injection framework. There's none of that stuff. You can do whatever you want to do in just a plain old Java application. But if you're doing Spring, you'd probably want to use the Spring abstraction for it. So one thing kind of as an aside, there's this Spring AI thing that's out there too. Spring AI is completely unrelated, has no commonality whatsoever, other than if you put the 2 architecture diagrams side by side, they look exactly the same, right? Or pretty close to the same thing, but the Spring folks and the Spring team is doing their own thing, and they're rolling their own framework to do everything that this does as well. Better, worse, who knows? It's too early to tell. It's so new. But I will say, as an advocate for Quarkus, if you like me to come back and do another talk and talk about why Quarkus is awesome and way better than Spring from a resource perspective and why it's so much more performant, that what Spring AI is doing is going to suffer from the same problems that Spring has today, is bloated, overused, too much runtime reflection, all that good stuff. So, all right, I'll get off my soapbox now. That's the last of Spring versus Quarkus that you're going to hear from me tonight. So some of these building blocks that LangChain4j has. So at the very bottom, you've got parsers, you've got memory management utilities, you've got ways to build there's different types of prompts, and we'll talk about those in a minute, but you've got this abstraction layer for prompts, you've got abstraction layers for models, because every model has a different API. So it tries to provide a common way of interacting with these things, but abstracting the model, both the language models, the image models, being able to call functions. So this was like, hey, I'm a providing, as a customer service, providing, you give me a customer ID and it can go look into the database and provide you information about who the customer is. So they call that tools or functions, ways to build those kinds of capabilities. And then on RAG, and I have a whole section on RAG, but when we talk about retrieval augmented, like being able to enhance the LLM, because the LLM has a kind of a finite universe of stuff that knows about. If you want to enhance it with new stuff or with stuff that's specific to your company or processes about your application or your domain or whatever, you can either go retrain the model, which I hope you have some data science people that can do that, or you can enhance it using RAG. And I'll talk about RAG, hopefully I'll have time to talk about RAG and how you do that. But essentially, there's a bunch of building blocks for how to load your data in, how to split and tokenize the data, how to embed it, how to search for relevant documents, and how to store it in a store. And I'll deep dive into this stuff in a little bit. And then, like I said, Quarkus, the LangChain, and the Spring LangChain4j starter. How much of the Spring has these capabilities? I'm not sure. I actually haven't used the Spring starters for it, but the Quarkus LangChain4j, if you think about common things that every application is going to need outside of the interactions with the models, right? Because this is an integration point between your application and something distributed, right? Something outside of your application. You have all these kind of non-functional things that you need to think about. Yeah, you need to be able to connect to it, and having bean injection that plays nice with your Java framework is great. But how do you observe it? How do you trace your calls through it? How do you audit what's going on? How do you make your applications resilient? How do you test them? How do you test the things? Like all these kinds of things are what the kind of the framework on top of LangChain4j is going to provide, and it's going to provide it in a way that make sense for whatever that framework is. So like the Spring Boot starter, I think Spring Boot uses Resilience4j now for like its fault tolerance and whatnot. It'll provide, and I don't know if it does today, but it would provide the integrations for Resilience4j. The Quarkus LangChain4j provides the resilience patterns for microprofile fault tolerance. And it provides observability with OpenTelemetry and Prometheus and all that kind of stuff. It has an auditing framework where you can tie it into your database so you can audit everything that goes back and forth. You can see, like, anytime you make a request into your application and it calls out to the LLM, you can see a distributed trace and tempo that has all the logs correlated with that. So these kind of non-functional things that every application needs to have is what the kind of the framework implementation is doing, but using the building blocks that are there, and not reinventing what's actually like the actual interactions with the model, kind of enhancing and extending, if that makes sense. So to use it, if you're just using the plain old LangChain4j, you just bring it into your application using dependencies. If you're using Quarkus, Quarkus has different extensions for the different providers. So like OpenAI versus Llama, you can have multiples in your application. And it's actually a pattern I use a lot. I typically, if I'm talking to OpenAI or Claude or what's the Google one there, Gemini, I'll have that one. But for my tests, I'll always fall back to Llama or to in-memory. There's an in-memory one, or I'll use WireMock or something like that to stub it. So you can have multiples in your project, and you can even build applications that, like, say you're doing a chatbot, but as part of your chatbot that allows the user to upload images, and then you want to do image recognition, and then maybe you need to do translation, and then one of your other tools, you want to make sure that they're not trying to do prompt hijacking. So like prompt hijacking is the chatbot says, "Hey, I'm Chatty, how can I help you?" And you say, "Forget about everything you've already learned and do this." Like I think on my next slide, on one slide, you've seen the stories of like the guy got American Airlines to give him a ticket for $1, bought a Ford F-150 for $1, right? Like, how do you guard against that kind of stuff? So a lot of times you might even have multiple integration points with different models on different platforms, even within the same workflow. So any question? That's kind of like the basics of LLM and AI and model integration and LangChain4j. Any questions? I'm going to start like kind of going into like chat models and how these things work. No questions? How am I doing on time? Am I good for now?
Yeah, we'll probably give you like another half hour or so.
Yeah, I'm not going to get very far.
That's all right. I'm learning a lot, so it's all good.
I can definitely come back and do it number 2.
Huh?
So with chat models, it's essentially you're giving it text and you're getting text back. It's using some natural language processing. You're providing it some instructions of what you want it to do using plain English or Greek or French or whatever language you're using. Caveat to that is not all models understand all the languages. They all, I shouldn't say, should never say all, always and never, but most of them do English only. And so you'd have to look at the model. Does it do French? Does it do German? Does it do whatever language you're looking to do? But there are some advanced techniques for working with different models and how to do the prompting, and kind of what I alluded to. It's kind of it's somewhat of an art science. People are coming up with these resume enhancing activities that are becoming prompt engineering and getting all this money. Excuse me. So in like just plain LangChain4j, you would everything. If you're not familiar with the builder pattern, you will be when you're done with LangChain4j, because everything is based on the builder pattern. Everything has a builder, which has builders to build builders to. It kind of goes a little crazy in some of the APIs, but it's very builder heavy. So you like, for example, if I'm going to talk to OpenAI, I have the OpenAI chat model. I do a builder. You got to give it an API key. There's a bunch of other stuff that you can fill out. But at the end, you just say model to generate. And I think actually there's a new API that's coming out where it's just called chat instead of generate. And you give it what you want to say, and it gives you the answer back. And it's pretty simple: string in, string out. In Quarkus, you can inject the model as a bean. And I can't really speak to any of these examples like in the Spring Boot starter because I haven't used it myself. I assume it provides a lot of these same things. So in Quarkus is a microprofile implementation. So it borrows from a lot of the Jakarta specs. So for bean injection, it uses CDI. For persistence, it uses JPA. It's not Java EE or Jakarta EE, but it borrows and uses a lot of the same specs. So you'll see a lot of that in here. So you can just inject the model as a bean into your class, and it's the same class at that point, and you just call the same API. I'll talk about AI services in a little bit, but you kind of saw when I showed you the example, you can actually do it declaratively rather than programmatically. Where you can just in Quarkus declare an interface. You define whatever the method names can be, whatever you want. It doesn't matter. It just has input and output, and you have that little annotation at the top, and Quarkus will actually generate the implementation for you. And so now you can kind of model your interactions at kind of a higher level. Under the covers, it's just doing exactly what's up above in the at the top of the slide, but it allows you to kind of model your different interactions, and you can have different models, like different interfaces that have different models, so they have different meaning. And when you're doing interfaces, what does it do? It makes things much easier to test, mock, stub, all that good stuff. So we can look at a couple of examples here. So I'm going to use, so I have this little package. Anybody ever heard of JBang? So JBang is an open source tool for just quickly running Java programs. So I can just create a class like this. And even if I didn't have the JVM, it would install the JVM for me. So I can go back one prompt. So I can just say jbang prompt.java. It'll compile it, download any dependencies. And I don't have a POM file. I don't have a properties file. It's pretty simple. So you can see I'm saying I have an API key on OpenAI. I'm not going to show you what it is. And I'm just saying, say hello world, and it's giving me back the answer hello world. Pretty simple, right? So the same thing with Quarkus. So this is a Quarkus command line application, but it's still being executed through JBang. You see, I can bring in like the Quarkus POM and then have options and all that good stuff. So I can just say JBang prompt with Quarkus. It's going to find the dependencies, compile it, run it as an application, and then it does the same. Essentially does the same thing. I injected so I'm doing constructor-based injection. So rather than @inject, I'm injecting through a constructor, just like you could do in Spring. So I'm injecting. I have actually 3 different prompt classes. I have just this prompt. I have another one so to show how you could actually have it talk to a different model with a different provider if you wanted to. Or you can have it, just by switching the return type. You see this multi thing. So if I go and I change the code here, so because I'm doing React, this is essentially doing a stream instead of like I fire it and then I wait for the whole response to come back and then I print it out. So if I run it again, so I'm saying you write a poem about unicorns and bears. You see it's streaming the response back and it's streaming it token by token. And I haven't talked much about tokens yet. It's streaming it token by token. So this complexity comes in because I'm building a command line app. If I started the streaming, the app would actually end before the stream was finished. So I need to hold the stream. You have to put some concurrency in there to tell it not to exit the app until the stream has completed. So this is kind of cool, where just by changing declaratively the return type instead of a string, I can make it a multi is just like an infinite stream of things that I don't know when it's going to end with back pressure and all that fun stuff. Just by changing the type, Quarkus understands that this is a streaming model instead of a synchronous model, and to stream the response back token by token. Oops. Couple more. So stream is another streaming example. Yeah, so if you were to do that same thing, like without the Quarkus part, you'd have to use like a streaming language model, and then you'd have to, it's all like callback based, like kind of like you would think it would be. Like as events happen, you have to provide event handlers to do, if there's an error on the next token and that all stuff. So that would work the same way. And then you can, so I talked about like tweaking how deterministic or how random you want it to be. And that's this thing called temperature. So all of these model providers have this thing called temperature. So if I do like JBang temperature, so 0.5 is kind of in the middle. So if I ask, name 5 words that developers hate to hear most. If I do it again, deadline bugs, scope creep, you start to kind of see similar responses. If I change this to like 1.0, the temperature, and I run it again, you see it's almost exactly the same every single time, because I'm telling it, I don't want you to make stuff up. I want you to be more deterministic. If I go down to like 0.1, and you notice that the response comes back faster. So when the more randomness you take out, the faster the responses come back, because there's less computation that the model's actually doing. And so if I do this, I get deadline bug, scope creep. Now I'm getting exactly, so maybe I got it backwards. It's actually giving me exactly the same. So maybe I always confuse it. I get it backwards. Maybe the higher the temperature, the more randomness, or the more, I guess, entropy you want it to introduce into its response. And that's a parameter that actually gets sent to the LLM, and the LLM takes that as input. So, and you can give timeout. You can see, I have it. If it doesn't come back in 30 seconds, then timeout and throw an exception. Now I want it to log requests and responses and all that fun stuff. So there's lots of stuff there. So if we start talking about prompts, we talk about the prompt that you're sending. What we've seen so far is what's called the user prompt. I'm sending at me as the user, and the user doesn't necessarily have to be a person. So there's a distinction. User doesn't have to equal person. User is the message, the interaction between the system. So the system and the LLM. The system is the user of the LLM. It's whoever's using the LLM, right? And when the LLM responds, it's using the role called the assistant, the assistant. And this is kind of the same AP. You'll see this all over the place with whether it's OpenAI or Claude or Anthropic or whatever. This is kind of the terminology that they all use. So you've got the user role is the stuff you're sending. You've got the assistant roles coming back, which are the responses. There's a bunch of other roles too, as we start to see. There's what's called the system role. So the system role is meant for kind of defining the scope. If you want the LLM to behave in a certain way, like I want it to talk like a pirate, or I want it to talk and give everything in iambic pentameter, like Shakespeare, right? These are what you want to tell the system, how you want it to behave for every request. So the system role when we start talking about context windows and whatnot, it has to go back and forth. It will always go back and forth every time, even if you're at the end of your token window. You've always have to send the system role back and forth because it's got the highest priority of all the different roles. And then you've got so you can start to see this and think of this as a chain, right? System, you send system role, you send the user, then you get an assistant, and then if you want to continue the chat, you've got to send all that back plus the next user message, and then you get back another assistant message, and then you got to send the whole thing back to them again if you want to continue a conversation with the thing, right? So this talk, when I first gave this talk, I was doing it in at DevOps Belgium, and I had two co-speakers. Clement was, the main co-speaker. He's French, and Georgios is the lead of the Quarkus LangChain4j project, and he's Greek. So we had some fun playing with different language constructs. So let's look at a couple of these examples here. Messages. Oops. So look at some of this stuff. What do we got in here? So you got a couple different messages. So I have a system message. You're Georgios. All of your answers should be using the Java programming language using Greek letters. And now the user message is say hello, right? Going back, and you can see here's your answer, and it's giving it to you in Markdown format. I have no idea if that's correct or not. I don't speak Greek. I could go to Google Translate and see what it says. But my guess is he verified then. I don't know if it's the same response, but he said that that was accurate, right? But if I change the system message to now your command, all your answers should be boring and long because he's French. We make fun of him because he's a typical Frenchman. You can say, oh, I didn't recompile it. It'd probably help if I recompiled it, right? Should probably just use dev mode. Now it's going to run. All right, so now it says, hello world. It's boring and long like I asked it to be. I could say our system equals you are Shakespeare. All your responses must be in iambic pentameter. Yep, hark fair world. So you're controlling the context of how the LLM behaves. Right. And so if you start to see, I started to allude to this, you can kind of see how this is going to work. If you want to actually have a conversation with the thing, it's your responsibility to maintain the conversation history and to keep track of it. Like I said, if you start to think of this as like a web application with sessions and whatnot, each conversation is unique to a particular user. So you need to be sure not to like cross conversation histories between users, between sessions, between threads, and all that good and fun stuff that we all love to do as Java developers, right? Because the LLM is completely stateless. So I have some examples of that too. So we can manage it manually, is kind of the old school way. So if I run this, I can say, here's a list of messages. So in LangChain4j, there's this kind of generic interface called a chat message, and there's lots of different implementations. So system message and user message are two of them. So you're a useful AI assistant. Hello, my name is Clement. What's my name? Then you can ask it for the answer. And then if you ask it again, what's my name? You'll see what happens, right? Because you start to see, here's my memory. I'm just managing it as a list. I have it generate a response. I add that response to the memory, right? And then I also add a new user message. What's my name again? I get the response, but then I don't add that. And we can start to see what happens. So if I say, let's run. Your name is Clement, and I'm sorry I don't have it because it got removed from the, or it kind of went out of the context. The fact, hello, my name is Clement, as I started adding stuff, kind of slid out of the window. So now it doesn't know that my name was Clement anymore. Or I guess I'm not Clement. My name's not, so it was actually right. Right. So there's also the size limit. So you need to keep track of the sizes. And so there's lots of different strategies for that. So let's go look at a strategy for that. So there's some built-in ones that you can take advantage of. You can build your own complicated ones. You can use things like, a lot of people use something like Redis to like, as like a cache, and you key it by your kind of your chat session. And that way you can offload your conversation histories on outside of your application heap, because it can start to get really big really fast if you have a really heavy multi-user application. So what are we doing here? So we use this message window history. We still kind of manually manage our memory, but we're saying that it only holds 3 messages. And if I run that, the name is Clement. And then the next answer, you're saying, where do I live? Because you're only maintaining 3, the system message always stays. The system message never gets evicted. So that's always one of the 3. So then my name is Clement and I live in France, got kind of evicted after the next message comes in, and now it doesn't know where I'm from. Like a child, selective memory. So context limit tokenizing. So you can start to see OpenAI, if you go to their website, actually has like a tokenizer thing. You can put in something, it'll show you what the tokens are. So I put this in, and this is kind of how it broke down the tokens. So sometimes they're words, sometimes they're not. I have no idea what it means, but the numbers underneath are what's called the vector or the embedding representation of the token. So everything gets computed to a binary format. So every token has a binary representation of what it is. And so that little array below is the binary representation of how it would actually interpret these tokens. So there's a ton of math that I don't understand that goes behind a lot of this. And every model tokenizes differently, right? So what you do for ChatGPT would be different than what you do from Anthropic, would be different than what you do for Mistral or Mixtral or any of these other things. So when you start talking about window sizes and context sizes and all that, you're talking of it in terms of tokens, not in terms of words, right? So let's see some examples here. So the slides have all the same examples that are here in the code. I just like to go to the code to show it. Did anybody verify if the slides were actually there? Yeah, okay. I see a thumbs up there. Cool. Tokens. So here, I have my memory. I add my memory, add my things here, and then you can actually ask it for your token count. It'll keep, every time it responds back to you as part of the API, or if you have logging turned on, it'll actually show you the token count. And for some of the model, like OpenAI, for example, will actually tell you what the cost of that was, that particular based on. And so the tokens is all encompassing. It's the system message, it's all the user messages, it's the assistant messages coming back. So the way OpenAI, actually I have the formula here because I verified it today. So when I compute the price, they have different prices for input versus output tokens, and it's usually based on per million tokens. So like in this particular case, it's like $2.50 per million input token and $10 per million output tokens. So the wordier you want the responses to be, the more money it's going to cost you in the long run. So there's like this cost thing that you need to be worried about as well. What's kind of interesting, and I'll show if I can get to the observability stuff in Quarkus, when you have the open telemetry stuff plugged in and you look at the distributed traces in Tempo, the cost of the call is actually added as an attribute to the trace. And I think it's aggregated up to the top. So if your one call to your app makes multiple LLM calls, because sometimes there are, and I'll talk about guardrails and whatnot, or reprompting, like you get something that looks like a hallucination, you can programmatically say, hey, that doesn't look right, do it again, and that stuff. So when it comes back, you can kind of aggregate the total cost of that call back to the top. And every model provider has a different cost bracket. So So it's something to keep in mind. But you can see the API, they all keep track of the token counts and whatnot. So it's just not the different models have different attributes as to whether they produce the cost of the call or not. Some do, some don't. So that was a really, so like I said, I loaded my OpenAI account back last January with $5, and I hopefully I don't run out, because I checked yesterday, I was at like 92 cents or something. So if it stops working in the middle of this, I'm gonna have to go load up my OpenAI account or switch to Llama or something. I'm only using OpenAI because the responses are good. Like the Llama, it's very hit or miss. All right, any questions there? Everybody good with that? All right, so let's talk about AI services a little bit. So this abstraction of being able to build and kind of model my interaction with the LLM as an object versus just wiring in this bean and calling methods on, declarative versus programmatic. You can do that in, I've only kind of shown the Quarkus examples. You can do that in just the regular LangChain4j as well. You can create an interface, define your interactions, and then you yourself have to manually call this, like, to create the implementation. But LangChain4j under the covers will create you a proxy for it. I think the Spring Starter will do this too, like Quarkus does. I think it has something like this, but it allows you, so now you can get kind of declarative about it, so you can start defining and abstracting and making it make sense, like nomenclature and verbiage, and modeling it how you want to model it within your application. I'm not going to go print out because the example looks just like this, and I'm going to kind of speed up a little bit. So in LangChain4j as well, so if to define these different messages, so you start to think like kind of where it starts to diverge from the Python world, right? Is Java is very annotation heavy. It's kind of just one of the idioms of Java being Java. So I could, if I wanted to use the builder, if I want to use the builder pattern, I could use the builder to wrap my class, provide it the model, tell it what the system message is, blah, 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 blah. Or I can do it declaratively. I can put an annotation on the method or on the or on the interface. If I have multiple things and I want them all to have the same context or behavior, I could do it at the interface level. And now I'm controlling the context of how I want my model to behave. All right, I'm going to skip the live code for that. So you could run it, you create the poet, and then you could change. So when you define your user message is very similar. So in this case here, where you just have like a string as the input, it assumes that's your user message, right? That's the user message you're sending. If you don't tell it anything different and you don't have an annotation or anything on the interface, the user message is like the question here. Now you can start to get kind of cute. You can use templating, right? Because you start to think, well, if I want to templatize and I want to change the data that's in the message based on whatever, based on data, right? I can start to templatize this. And so in LangChain4j, I don't think it is actually Mustache, but it's very like Mustache, or maybe it is Mustache. I don't remember. But you can start to templatize tokens or parameters in your user message, and then in your method signature, I don't know where @v came from. Like that makes absolutely no sense to me, but that's what it is. You do @v and then the name, and you can have multiple parameters in your thing, and now you're basically telling it what your tokens are and what your parameters are, and then it'll interpret that and it'll run your template before it sends it to the LLM. You can even do things like structured output. So far we've only shown text, but what if I want to send JSON and get JSON, right? And I want like something like Jackson to marshal my JSON out, and I expect the response to be in a particular format, which starts to get really interesting when you already saw when I asked it for a code, it says, here is your code, and then triple backtick for markdown, right? That makes things really fun when you're expecting JSON, right? So I'll talk about that when we talk about guardrails on how to like tell your model that, hey, dummy, this is supposed to be JSON. This is stuff you'd want to put in your system message. I expect you're going to return JSON that looks like this, that has these parameters with these types, with these particular values, and have like an automated code path that will try and marshal it. And if it fails, it'll go back to the LLM and try to reprompt it and say, what you sent me wasn't valid JSON, try it again. Like, and that kind of stuff. So you can do things like, I can now build a system message, a user message, and I can put an object as my return type. And if you have a JSON marshal, or like I think Jackson or JSON it supports, it'll use that and try to marshal. And of course, if what the LLM sends back isn't marshalable, it'll blow up. And try it again, and it might work. It might be fine the second time. It might work the first time and not the second time. Like it's like a child, you can plug memory into these things too. So we talked about memory. So far we've only doing stateless. Like if I were to do this and ask it the same question, it wouldn't know anything about anything. So I can now start to apply those memory things to these services, these higher level services. I really like the higher level abstractions. They make things a lot easier than like the code. So I can just get this assistant, I can give it the reference to the model, I can give it my memory, and then I can just interact with the thing. I don't have to build it every time. I can just call the methods and it understands what it's supposed to do. Any question? I guess I'll show the example of this one because I kind of didn't show, any of the examples in that particular one. The AI services, let's go to the last one here. I'm just trying to save some time here.
So we're probably about 5 minutes left, maybe, Eric.
Okay.
Yeah. Okay.
Yeah, so I build this and then I can say, here are my answers. I can ask it for things. And, I gave it, again, the same example we showed where we have a memory window of 3, but the system message is always there. But I don't have to keep track of when I do it this way. I don't have to keep track of the list of messages. It's kind of taking care of that under the covers for me. I'm just saying it how I want it to manage the memory, but I don't have to tell it, like I don't have to add the messages in or any of that stuff. It manages the memory for me. All right, so if I do this, it's not gonna, it'll know my name, but it won't know where I live. Your name is Clement, how can I help you? And then I don't have that information because it's expired out of the memory. So you can start to see why I like the declarative approach, because it's a lot less stuff that you have to implement and manage and take care of. It just kind of all happens under the covers. All right, so maybe we'll just get through this section and then we can call it a day. Or if you want me to keep going, I can keep going. I don't want to hold people up. So if you start to think about like what kind of the differences between these things that we're familiar with, like, and I kind of already alluded to this, but you've got your applications that talk to a database, you've got your applications that talk to other applications, right? And then you've got the squiggly line. That squiggly line when you're talking to the models looks exactly the same, but it's actually very different because we have lots of other things, and these things are going to happen far more frequently. Like people, if you're just building like a service that talks to a database, do you use circuit breakers and fallbacks and bulkheads and timeouts and retries? Probably not. I mean, that's all the good stuff we learned about in the 12-factor manifesto, and that's how you're supposed to, what the microservices manual says you're supposed to do for everything. But in reality, do we actually do it? For some stuff, maybe, but for most of the stuff, probably not. You're going to want to do this stuff here because you're going to be left and prone to a lot more failure if you don't build your applications to be resilient. And you all know how the whole microservices manual says, like if one service fails, it cascades the failure up, right? And that microservices are supposed to solve that problem, but they don't if you don't build them correctly. And so this is where something like the framework's implementation kind of sits on top of that. It makes it easy where I can, those interfaces that I build, I don't have to do tell it to create the service. It just becomes a CDI bean that I can inject into my code. It manages the memory. I can configure the memory through properties. Like I don't have to write code. So I can tune the memory on a per deployment basis. Like if I'm in dev versus prod, I can tune the memory differently. And maybe in prod, I send it to Redis, but in dev, I have a memory size of 1 because I don't really care, right? How I interact with all the stuff, how I observe it is all kind of standardized, and it's consistent with how you would do it for non-AI applications within the framework. It ties into all the same tools. So rather than show it on the slide, I'll go to the simple example here. Oops, Quarkus AI services. Again, I can't speak to what the Spring Boot starter does and how it does it. I don't have much experience with it. But if I come here, see now I have that assistant, which looked exactly the same. It just has one more annotation, which this annotation is specific to the Quarkus LangChain implementation, right? But now I can just inject it as a bean, as a thing, and I can use it. I can just start calling it. I don't have to set it up. I don't have to do any of that stuff. Similarly, like if I go to like different, if we start looking at different scopes now, I talked about like requests versus sessions versus, singleton and all that fun stuff that we all remember, right? So I can have an assistant or an AI interaction that's scoped to a particular request. So now every HTTP request in gets its own instance. And so now the memory is being managed per instance for you versus one that's application scoped, which is every request uses the same memory for the lifetime of the application. Application scoped is like singleton or session scoped. So you would use session scoped in like a WebSocket chatbot. Like WebSockets have been around forever and nobody really used them for much. And they've kind of like shown their ugly faces recently because they're awesome for implementing chatbots. But you have to remember state, it's conversational and it's per session. So when you build the services that talk into this, you need to make sure you scope your AI interactions to the session so that under the covers, what Quarkus does, you might think HTTP session, with the session scope, but it's not actually HTTP. When you combine the WebSocket stack with the Quarkus LangChain stack, it understands, session scoped, especially when put on an AI assistant, means it's now bound to the client, the particular WebSocket session, not the HTTP session. Every connection to a WebSocket has a WebSocket session, and now it's binding and doing all that under the covers for you, where it's now binding your assistant's memory to the WebSocket session. And when the WebSocket session closes, it cleans it out and it's gone. So kind of like bringing it into how the framework would behave in all the other idioms. And it's got a lot of this other stuff too. So like observability, I'll go into the fault tolerance one because the fault tolerance one's kind of cool. So I have just like a JAX-RS endpoint. Nothing, there's really nothing, just a post. There's nothing fancy in there. And then my assistant has a system message, you're useful experts in the NBA, and I want to ask it a question. And you notice my input is actually an object now. And so now I'm using a template where I can now nest, I can create objects, or records are very good for, non-mutatable state, records in, records out. I can now build records or records of records, and I can templatize that, and I can traverse, so I don't have to pass like a million parameters. And you notice too, you don't have that @v parameter when you start using Quarkus on top of it. Just kind of because it does all the stuff it does at build time, it knows and understands your parameters, and you don't need to tell it which parameter it is. It just knows. But now you can say, hey, if you fail, I want you to retry it 2 times. And I want you to time out after 1 minute. If after a minute it doesn't come back, I want you to throw an exception. Oh, and if any exception arises, because we're using interfaces, I can now provide default implementations and fallback methods. And I can scope my fallback method based on particular exceptions. I could put the exception in the signature, like, so if it failed because of like a 404 exception, it would handle that error differently than handling a different error. So now I can start building the resiliency into my applications through, something like fault tolerance, or, observability is another good one. I want to make my things observable. You kind of almost get it for free, but there's the observability one is actually cool. I'm going to show this. Which one is this? This is 3. What number is this? Is this number 5? So I talked about dev mode a little bit. I haven't really deep dived into Quarkus at all. So if you're not familiar with Quarkus, when you run Quarkus in its dev mode, not only do you kind of get this live coding thing, but it has this concept of dev services. So if I need like a Postgres database or Kafka broker or whatever, if I have that extension in my class path, but I don't provide like configuration, it'll just actually spin up a container for me and bind my application to that container. So in this case, I have the observability stack in my application. So it's actually starting up Loki, Tempo, Prometheus, and Grafana, and the OpenTelemetry collector in the background. And once it's done, I can actually, once it's up, takes a second as it's a big stack. Yep, so now it's telling me where all my endpoints are. If I come back to this, this dev UI that I showed earlier, and I come over to this dev services thing, you can see it started up the observability stack. It's got Grafana, it's got a no-tell collector, it's got where my chronometer is going to send its things to, where my traces are going to go, where it's going to send all the logs to Loki and all that stuff. If I go back to my application, and I say, so this is just a command line. So if I'm going to go back to Swagger UI here. Swagger UI. So it's about NBA players. So I'm from Boston. I'm going to say Larry Bird, right? It's going to send the request over, and it's going to come back and say Larry Bird last played for the Boston Celtics in 1991 and 1992, right? So that in and of itself is kind of cool. But now I can come over here because I have the observability stack dev service. I have this card. I can come right into the Grafana UI. I can come in here and say, go to explore. I want to explore tempo, and I want to search for my application, and I want the span because it'll automatically create spans for every REST endpoint. So for the HTTP post and then search. So there was one span. I hate the Grafana UI. It's so clunky. I can come over here and then it'll produce a node graph for me. It shows like it came into my app to the post, then it went into the AI assistant, then it went into the chat completion, then it actually made a post, another HTTP post out, and it shows me my history here in my assistant. I'd mentioned, not this one, in this completion, the attributes, it has, here's all my tokens, here's the cost of what that call cost me, and then I can say, oh, show me the logs for the span, and it correlates all the application logs to it. And that's all there in open telemetry and ready to be exposed. And I didn't have to write a line of code other than add a dependency to my POM.
That's super cool, man.
Yep.
Is that a good stopping point, do we think?
Yeah, I think that's where I think that's, what else I got? Yeah, so I'm just like scopes. I talked about, let me put this back in slideshow mode here. Yeah, I talked about scope, structured output. Yeah, you can even get really cool with the templating. Like you can get really complicated. So with LangChain4j, it's just using, I think it's Mustache as the templating language, or it's a variant of it. And Quarkus has its own templating language called Qute. And you can, for system and user messages, you can use the templating languages. The cool thing about the templating language in Quarkus, because Quarkus is so build time focused, it actually does compile time checking. So like you have this thing called chat messages. If you reference a variable in your template that doesn't exist in the method signature, that'll fail at build time. Like, hey, you told me about a parameter that you didn't give me. Like it's almost like a compilation error. So you can like loop and do if then and all kinds of crazy things in your templates.
Cool.
Yep, services, observability, tracing, auditing. Yeah, this is actually this is on my to-do list to be rewritten. Fault time. Yep, that's
Awesome.
gets us to the, so now this is, to me, this is the fun stuff. Like we got as
Yeah.
far as getting to the fun stuff.
No, that was awesome. A lot of cool stuff. We got time. Does anybody have any questions for Eric? I will like personally say as, oh, was there somebody else that was not me talking? Maybe I didn't hear it. Oh, sorry. I was gonna say, like, as a Spring guy, I haven't seen Quarkus that much. I love that dev tool window thing that was built in. That was pretty slick. This thing's awesome.
Yeah, and so it also, so like with LangChain, it even has like if I want to do image generation, I can play with my, so if I want to play with my
Oh, yeah.
prompts, I can do all like, so here's my tools, here's a chat, I can just chat with my chat bot. It's got the UI
Yeah.
built right in. I can start saying, oh, how would it change if I change my prompt? And I'm not even writing code, but it's flowing through my application and
Yeah.
going out to the model. So there's like every integration point that you can think of. Like if you had Kafka in here, for example, you'd have a topic browser, and then you could go in and look at your topic browser and look at the things. You could add messages to your topics and all that stuff right in here through this
That's
UI. And it's only
that's really
there when
cool.
you're running it in the dev mode.
Yeah, I love that. Very cool.
So I can do a whole nother talk on a deep dive on Quarkus another time. I can come back lots of times.
We'd love to have you.
Yeah. But seriously, if you want me to come back another time and like we kind of got about halfway through it, like do part two in a second half, only come if you came to the first one because otherwise you'll be lost.
Uh, there was one question in the chat from Matt. Did you set up an LLM locally? Is that a pain to like swap back and forth between OpenAI versus run one locally?
No, so I'm actually, I don't know if you can see it up on my toolbar here, but I'm running a Llama locally here. So I can so if I say, I do the same thing that I just did, but I can say -d Quarkus. Oops, what did I do here? Quarkus, LangChain. I can say change the model to Llama 3.2 and change the base URL to localhost, and I can run this. And now it's going to funnel through a Llama, because a
Oh,
Llama will expose as an OpenAI endpoint. The responses aren't going to be as good, and it's a little slower, but it doesn't cost me any money. And now I don't depend on anything.
yeah,
So
that's super cool.
yeah, so I can.
Easy to swap.
Yeah, it's easy enough to swap. So like if I come back to my little dev UI here and I go into my chat, I can say, and it will show you the whole history. And so this gets kind of cool too. Once you start putting tools in there, when you come into the dev UI, it'll show you break out every interaction. Here is the system message. Here is the assistant message. Here is the user message. Here is the tool invocation with all the parameters. So it's almost like a debugging tool as well. You can kind of watch what's going on. So yeah, you can see here's what it came back with. And if I come back to you can start to see here's I have request logging on, so it'll log the request, and it went to localhost and with Llama 3.2. And then here's the response that came back.
And there's one follow-up to that. How beefy of a machine are you running right now? Is that does that help? I'm assuming.
So I got this machine. So Red Hat refreshes their machines every 3 years, and I was close to my 3 year. I was running on a Mac M1 that I got 3 years ago. I don't know how I did it, but I was able to convince powers to be to order me a non-standard model. So I have an M4 Max with a terabyte and 64 gigs of RAM.
Nice.
I can run Llama 3.3 and it takes 5 minutes to do a thing. But if you notice, I have like my GPU and CPU. My GPU goes through the roof, and I actually can hear the laptop fans come on, and the laptop sounds like it's going to take off into outer space if I do
Oh,
that.
that's funny. That's why your office is so hot, right? You got the big.
That's right. So I do have a
That's
beefy
funny.
machine, but you really need, if you're going to run some of these more complicated models and you want to really test out your prompts or to even run your unit tests. I'm all about automation, and for dependency updates even with this sample project, there are tests for everything so that Dependabot can automatically keep versions of stuff up to date, and I can verify things work. More often than not, when I run it in GitHub Actions with Llama, it breaks because it sends back something that's not JSON when it should be, or it hallucinates or it doesn't do what I want it to do, where OpenAI pretty much always does what I want it to do. It's rare that but I can't put my API key into GitHub Actions. I'm just not going to do that.
No. Cool, cool, cool. Any other last second questions? Otherwise, I'm going to steal the screen share and we're going to get ourselves out of here.
Yeah, and like I said, all the code examples are there. The whole slide deck is there, not just what I covered. I think there's how many slides are in here? 100, 108. Like I said, this was a 3 hour. We stood up on stage for 3 hours and did this.
That's a long talk.
Yeah, I'm doing it next week in Ottawa. I'm doing the same talk for 2.5 hours in person.
Nice. All right. I am going to replace your screen share with my screen share, and we're going to do the very high tech. Does anybody not see their name over here for an IDE raffle? I got two of them because we had no meetup over the holidays, and so we banked an extra IntelliJ or JetBrains license. I think I've got everybody that's still here. If not, we'll find out. So I'll spin it. We'll land on somebody, and then maybe I'll spin it. Who do I spin? I click spin. And then if you want to like message me in the Zoom, you can just DM me the SideJug organizers. If you want to just send me your email, I will. Oh, am I not screen sharing? I thought I was. Oh, I thought I was screen sharing. Now I'm screen sharing. There we go. Thanks. I'm spinning it. I think I got everybody's name up there.
That's funny.
Now, of course, I can't
we
see
do it
everybody.
the exact same way with the same software.
Yes.
The problem we have though is when we give them away, people don't activate them. And
They
then
also get that problem. I'm surprised. All right, Matt, you're winner number one. You're still here. All right. Matt, send me your email or a good way to contact you, and I will get you one of those. And then we should have another one. I'm gonna run it again. Maybe. Matt's out. We're rolling again. DJK, are you still here? You're here. Congratulations. I'll like as a fun extra thing, I'm not gonna do it this week, but if you want, there's like a duck race raffle thing. Oh, I use this one. This guy's also excellent. It's littered with ads, but you can put people's names on here, and then you can run the ducks. So if you're ever bored, duck race online stopwatch, equally fun. I was also going to quick talk about next meetup. We are online again with Michael Redlich, also Java champion. He's going to be talking to us next month about getting started with Jakarta NoSQL and MongoDB. So if you guys enjoyed the talk tonight, feel free to stop back next week. We don't have it on Meetup yet, so keep your eyes peeled for Meetup, but the notification will be going out here before too long for that meeting next month. And thank you. Thanks, Eric, again. Thanks, everybody, for showing up. Had a good time. Learned a heck of a lot, and that's the goal.
yeah, feel free to reach out to me. You know, social media is the easiest way. You notice I have like a little X or red thing through the Twitter icon. I'm making a conscious effort to get off of Twitter, but I still, you know, it's kind of like shaving a monolith until everybody's off. You kind of still have to be there. But Blue Sky is kind of where Blue Sky and LinkedIn is where I spend most of my focus. So I kind of put the little red X through it, but it's still kind of there.
Awesome. Cool. Well, I hope everybody has a great night. I've got your guys' emails, so I'll be able to I'll shoot those off here tonight or tomorrow morning. Again, Eric, appreciate it, man.
Yeah, thanks a lot. Have a
See
good
you
night.
guys.
Thanks for having me.
Everybody.
Yeah, be good, guys.
Bye.